Hi, it's Mr. Hayes. Thanks for joining me today here on Hayes' World of Math. I love helping people with whatever they're working on, whether it be math or something else, and today it just happens to be statistics. We're working our way through statmedics.com's lesson plans, and I like them a lot because they have this experience first, formalize later plan of actually allowing you to work with the math first before you start putting names to things, and I think that works out really well, and hopefully I can bring you some insights as we work through it. So by the end of this, topics will stick with you. So today we're looking at residuals, and we're going to be doing it through iPhone data. So over here, just try not to get ahead of myself here, but so over here we've got all the data. The iPhone was first sold back in 2007, and it sold just 500,000 units. If I remember correctly, it was rather pricey then. And then obviously, as you can see, as we go through, we've got lots and lots and lots of more what's going on. So the first thing I ask you guys to do is to go through and plot this out on your TI-85 calculator, or TI-84s. So if we do that, the best place to do it is to go over here. And what we do is go to Stat, remember, and you're going to go to Edit. And then you're going to go ahead and put the two datas into List 1 and List 2, or whatever two lists that you want. Those are going to be the easiest. Go ahead and hit pause if you need to catch up, if you're going to be following along with us. From there, what we're going to want to do next, in order to make sure that we can see what the stat plot is we're going to go up here to Stat Plot. So we're going to hit Second, Stat Plot. And we're going to go through, and it says, okay, the stat plot's on. I'm going to go ahead and hit Enter and go in there. You want the plot on. We want it to be stat plot here. We have list 1 and list 2, so whatever your two lists are, first one's going to be your x-axis, and the second one's going to be y, and then you can pick colors if you happen to have that type. Now, one of the best things that I learned a number of years ago in help with doing stat plots is that if and when you click on zoom, sometimes people want to make the perfect one using the window. What I found is if I hit zoom, there's this option down there at number 9 called zoom stat. And again, remember, you can arrow down or you can just press the number 9. And when you press number 9, it's going to zoom in along what's going on in terms of your stats. Now, if you needed to, you could then go back out here to window and change it to, let's say we wanted to go 0. So we want it from the year 2000. And now when we hit graph, it'll extend it out and you can see both sets of axes. Up to you, okay? So the first thing you're going to do back here is that you're going to go through and replot it out over here. And that's part of the reason why I had it hidden, because I didn't want to tip my hand. So then from there we ask, okay, describe the form of the distribution. It's like distribution looks nonlinear. Why am I saying nonlinear? Now, as I go through and do this, you can I used to actually give out pieces of spaghetti for this. It's kind of linear, but you know that this is going to tail off, right? So that's starting at 0. It's kind of curving here. We kind of get this bump or swell over here, and then it's starting to kind of dip around there. So we need to, the whole reason for what we're doing today is trying to say how, if you remember from the residual before and getting the R values, we're going to kind of say, well, where are we at with it? Let's go ahead and take a look. But we're going to use that idea of residuals and kind of come in and actually make it so we could see it better. So we say, is this really nonlinear or not? Okay. So next thing we're going to do is we're going to use the least squares regression line, write the equation below. Okay, so if you remember that, let's go back. Sorry for the extra numbers, but that's what I have to use to change from scene to scene. What we're going to do that, we're going to go to stat. Now again, remember, we still have all of our data here, right? So we're going to click on stat, and we're going to go over to calc. And we want linear regression. I'm going to show you a neat little trick that actually works out really, really kind of nice. And it doesn't matter which one you do, but I will say most of the time in the things that you will see in statistics, they tend to put the starting point first and then the slope second. So we're going to go ahead and choose number 8. Now, here's the place where, again, updating your calculator is always a good idea. It can really pay off. List 1, list 2, x, y, y list. And you can go ahead and run this and get a fine, nice line. But what you can do is over here, it says store the regression equation. If you click on the variable button here, you can then store it into one of your y equals. And so then that way you can graph it really, really nice and come back to it. So you can click y. And I want to make it a y variable, so I'm going to arrow over to that menu. We're going to do functions because we're not doing parametrics or polars. So you can function, and I want to put it in y1. So when I do that, and I hit calculate, I've got my equation. Okay, in fact, I'm going to write that down. So we're going to write it down two ways. We're going to write it in terms of math. Remember, it's going to be y hat. Actually, let me go ahead and bring us all back here. Y hat is going to equal, oh, just lost it on my screen as I typed. My apologies to all of you waiting there at home. So it is a negative 11.654. And let's just go 6.5. Yeah, let's go 3. 6.54. Always go to bit better to go a little bit more than less. My apologies. 6.54 plus, what's their slope? And that's a negative. And then 1.507. And then an x. So if we're going to translate that, we're going to say our predicted units sold. Remember that little hat there tells us it's predicted, is going to equal a negative 11.654 units. And that would be back when. In our case, it's going to be the year 2000. Plus 1.507. Now, what is X really standing for? X is years, so I'm going to put down years here. And again, the reason why I think I said this is the last one, we do it in math and we do it in English. The nice thing about writing it out in English is then again, it's driving home what these variables are meaning. Okay? So, use a least squares regression line to calculate out the residual for 2007. Great. So, what we do is we're going to use this equation here. So, we're going to say, okay, units sold. Make sure I'm on the screen. So, predicted units sold is going to be a negative 11.654 plus 1.507. I know this is exciting. I can just tell that you're just like, ooh. So if I type that in to my handy dandy calculator, I get Mr. Hayes, we really should have paused. Actually, I've got them all stuff down here. So for year 7, it is going to be, I get a negative 1.11. Then it says, okay, so that's just the value, right? And so then we want, it says interpret the residual. How do we find the residual? Well, remember what's going on here is that you interpret this, so you're going to actually go through here. So the residual here is how much did they sell? So actually, let's do it right here. Okay, it is going to be actual minus the predicted. So we're saying how far above or below that line do we having it? So what we're saying here, if we look back up here, we have this line coming down like this. We actually have a negative value for 2007. Okay, the residual, remember, matches, it would be the distance from this actual point down to what the predicted point is. Okay, so in this case, we know it's going to be positive. All right. So we're going to go through and you're going to complete the table down below. So, oh, wait, we forgot the interpretation, Mr. Hayes. You're right. The actual number of units sold in 2007 is 1.61 million more than predicted. Ta-da! All right, so then what we can do down here is that we're going to have to plug through all of these different values into our equation, right? So we're going to go through and wrote this out earlier and then I made a mistake, so pardon the post-it. So these are all the predicted values. So all of these, the the 7, the 8, the 9, all the way up to 18 ran through this prediction equation up over here. And so then I got boom, 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 boom. And then for the residual, remember we're doing actual minus the predicted to figure out what the residual is. Now, I know I'm throwing a lot of calculator stuff at you. Check this one out. So if you go to y equals, let me get back over here and get the right screen up for y'all. There you go. So we've got our least squares regression line right there. Now, if you go over to stat and if you go over to edit, you can do math within the tables. So a couple of things. Remember, this is my x value, this is my y value. So I'm going to go over here in number 4, and if you go up into list 4, you can say I'm going to make list 4 equal to. Now remember what we're doing for the residual values, right? We're taking the value that we're expecting, so in this case here, let's go back here for a second. So we're taking this value right here, the actual value, so this would be, let's say, like L2. And this right here is everything that was in list 1 ran through my y value. And then I subtracted those two. So if you're feeling really on top of it, or if you do a lot of practice, check this out. So what I'm going to do is I'm going to go up here. So, and you have to do it up in the list part because that's going to allow you to do the formulas for math. So I'm going to say I want to take the value of list 2, so second list 2, minus. Now, to plug in this column into y, what you're going to do is you go to variables again, go over to y variables, choose the y variable that you want, so in this case y1, and in parentheses, I'm going to run L1 through it. Ready for the magic? Boom! You got it. So those are the things, and so then that actually, now all those numbers correspond with what I wrote right here. So again, as long as you understand what's going on, you can use the calculator to your benefit, and it's amazing! I know. Okay, so now here's the part where we're going to actually, and that's all important, and it's fine, and you can do it by hand, and it's all great. Over here, the residual plot is the one that we're actually going to go through and do, is the important part. So what you're going to do is that you're going to plot the residuals against the year. So like this one's 1.6, so for 2007, we'd be up about here. For 2008, we're about here. 2009 is a negative, almost 0.1. And what you end up seeing here is that it's easier to see the pattern against the line. And you could, I mean, if you drew the line, plotted the least squares regression line here, and I can even show you that here, actually, let's even do that, because you guys are worth it. If I hit graph, see, there's the least squares regression line. You can kind of see what's going on here, but the residual plot makes it much, much cleaner. So 2011 goes to negative 0.92 again. 12 comes back down here to about 1.43. 13 is 1.06. 14 is 0.05. 15 is 2 and change. 16 is almost down to 0. 17 and then 18 would be two negative numbers about here and here. Great. Why do we care? This is why we care. Check this out. Okay. So what ends up happening, let's make sure we can see all of that. So there's a residual plot. This axis right here, okay, this right here is basically our least squares regression line, okay? And so that's a benefit because what ends up happening then is now you're seeing, instead of seeing it back compared to in here and then trying to gauge it, it's everything has been basically, it's not been turned on its side because you're still measuring the distance directly up and down from the line, but it gives you a very clear idea of where things are at. Okay, so over here in question 6 on the next page, for which points was the actual greater than predicted? So where was that? That was here, and that was over here. So these were actual bigger than predicted. And this is where things were less than predicted. Why is that important? Whoa, somebody should have yelled, I'm sorry. Why that's important is it gives you an idea of whether or not it's a good fit. If it's a good fit, you should just see, you remember what your science teacher told you when you're drawing the line of best fit, right? It should be kind of equally, go through all the points kind of equally spaced. And the same thing happens here. Now notice here, you kind of start up, you go down, you start up, you go down, et cetera, et cetera. So you're kind of getting this wave pattern going on. And so because of that, in this little tiny spot here, I would say, do you think the regression line is a good fit? Why or why not? Explain using the residual plot. And so you'd say, no, the residual plot looks curved. So the distribution was nonlinear. Okay. Why? Because there was a what it was, positive, negative, positive, negative. So there was a positive, negative, positive, negative. Oops, pattern. I should have written that out. Sorry. All right. So that ends part one. So we're going to formalize it down here in a second. We'll see you back for that.